So question 5. This question is about acid and alkalis. Question 5.1. Ethanoic acid is a weak acid. What is meant by weak acid? Answer in terms of ionization. So for a weak acid, we can say a weak acid is only partially ionized in aqueous solution. What does that mean? This is what it means. If I have a ethanoic acid, so this is ethanoic acid in a solution of water, there's an arrow going forward, a shorter arrow, and a longer arrow going backwards, which means this acid preferred to be here, not there. So only a tiny small amount will go into product. That's what we mean by partially ionized. And this is the ionization here. So it's losing H+. That's a proton donor. That's what acid do. They release H+, and that's the plus H. So that's the H+, but only a tiny bit of this acid will go to that direction. The rest will stay here. So that means it is partially ionized in aqueous solution. That's why the arrow here is longer. It means this will go there and only a small amount will go there. So this is the ionization process here. So you're creating ion, a negative ion and a positive ion ionized. Question 5.2. So if we look at question 5.2, the concentration of an acid can be measured in mole per decimeter cube. Which combination of changes increases the concentration of an acid? So we are looking at the situation here. The mass of acid dissolved is half, and the volume of acid and the volume of the solution is half. So volume is the liquid, mass is the amount which is dissolved in the liquid. So what we can do is write down the definition for concentration here, because we're looking at changing concentration. Two ways you can write concentration: mole over volume, that's mole divided by the volume, or mass over volume. So we're going to use mass over volume because the question is using mass over volume. And if the mass of the acid dissolved is half and the volume of the solution is half, so let's see what that meant. Here's a mass over 2 and the volume over 2. Will this still give us this mass over volume? Well, we can do that by rearranging it. So fraction divided by fraction, and then you will need to invert it, turn it into times the. So that will be the 2 we cancel, and we're still going to get the mass over volume. So there's no change. So that is still the same compared to that. So no change. And we want change, increase in the concentration. So that would work. Next one will be this one. The mass of acid dissolved is half. So the mass of acid dissolved is half, and the volume of the solution is double. Okay, let's see what that meant. So we got the mass of the acid dissolved, which is this one here, is half m over 2, then divided by the volume, which is twice the volume. That's 2v over 1. Again, we do the mole fraction. So 2m over 2 times 1 over 2v. The volume is doubled. And so we're going to get m over 4. So that meant the concentration has decreased by a quarter. So that's not good. What about the next one? The mass of the solution dissolved is doubled. So that's 2m over 1. And the volume of the solution is half. So that'd be v over 2. Okay. Again, we do the fraction division here. So we're going to do 2m over 1 times 2 over v. We can have that equal to, so that would be 4m over v. So this is 4 times that one. So that's an increase. So it means that would be the answer. Well, what about this one here? This one says the mass of the dissolved is doubled and the volume is also doubled. So that'll be 2m over 2v, and the 2 will cancel out. So you're going to get just m over v. So no change for this one. So the only one that has a change is going to be that one. So that's the answer. Question 5.3. This question is: the concentration of an acid can be determined by titration. An indicator is added to an alkali in a flask. Name an indicator that can be used in this titration. Give the color change of the indicator when acid from a burette is added to the alkali in the flask. Well, there are a few indicators you could use. Methyl orange is good. So you change the color from yellow to red, or it could be that you change it from yellow to orange, or you might say pink. So that's correct. There are other examples you could use. You could use phenolphthalein, and that could change from pink to colorless. or you could use a litmus paper, and that will be from blue to red. So those are the examples you could use. That's 2 marks. Any one of those and all these will do. Question 5.4. Sodium carbonate dissolved in water to produce an alkaline solution. Give the formula of the ion that makes a solution alkaline. What we want to do now is to write the sodium carbonate here plus water. That should give us sodium hydroxide. Obviously you got 2 sodium here, so you have to put 2 sodium there. Sodium hydroxide, imbalancing that. And the sodium hydroxide here will then split into sodium, but we look at that in a minute. So sodium hydroxide plus carbon dioxide. So the sodium hydroxide will split into sodium plus iron, and so those are the ions we're talking about here, plus 2 OH minus. The alkaline ions here we're talking about is the OH minus. So this is your answer. And question 5.5. For question 5.5, a student does a titration using sodium carbonate solution and nitric acid. The equation for the reaction is shown below. 25 centimeter cube of 0.124 mole per decimeter cube of sodium carbonate solution is neutralized by 23.6 centimeter cube of nitric acid. Calculate the concentration of nitric acid. Give your answer to 3 significant figures, You should calculate point 1, the number of moles of sodium carbonate in 25 centimeter cube of the solution, the number of mole of nitric acid in 23.6 centimeter cube of the nitric acid, and the concentration of the nitric acid in mole per decimeter cube. This is 1 mole of sodium carbonate reacting with 2 mole of nitric acid to give 2 mole of sodium nitrate, 1 mole of carbon dioxide, 1 mole of water. Those mole numbers are stoichiometric mole. So first thing we need to do is, you could see that we got concentration of the base. Here's the base. Concentration of the base, here's the base, is equal to 0.124 mole per decimeter cube. And we also have the volume of the base. The base is 25 centimeter cube. So we write 25 divided by 1000. That converts it to decimeter cube. We also have the volume of acid. So the volume of acid is 23.6 centimeter cube. We convert that to decimeter cube by dividing it by 1000. What we could have done is, we also can write down the stoichiometric mole of the acid, which is this, and that's 2, and stoichiometric mole of the base, this is 1 here, stoichiometric mole of the base, this is 1 here, and we could then use this formula here, the concentration of acid times the volume of acid, this is the mole, divided by stoichiometric mole, will be equal to concentration of base times volume of base, divided by the stoichiometric mole of base. We could have used this and then make the concentration of acid, which is what we're looking for, the subject, and then we get this. But the question is asking us we could do this by getting that straight away. But the question wants us to show this and that, so we have to do that. So first thing to do is to find a mole of the base, sodium carbonate, and the mole will be the concentration of base times volume of base, and that is, we know the concentration of the base is 0.124 times the volume, which is 25 over 1000. And that will give us 0.0031 mole. So that's the mole. So that answers the first question there. The second question is this one here. The mole of acid is twice the mole of the base, because the equation that we had was the stoichiometric mole of acid is twice the mole of the base. Therefore, if we know the mole of base, we can multiply by 2 to get mole of acid. So that's what we did. 0.0031 times 2. That will give us the mole of acid. So that's the mole of acid. So we've done that one. That's question number 2. Now we need to do the final question here. So we could do that, or we can just use this. So the final question, we need to calculate the concentration of acid. Since we already know the mole, concentration is mole over volume, we know the mole of the acid, which is that one, and we know the volume of acid as well. So we could do 0.0062, that's the mole of acid, divided by the volume, which is 23.6 divided by 1000. And that will give us, so that would be, we can rearrange that like that. So, and then we get the volume of concentration of acid to be 0.262622711, and to 3 significant figures it will be 0.263. So that will be the concentration of the acid. Question 5.6. When hydrochloric acid dissolves in water, hydrogen ions H+ and chloride ions Cl- are produced. A solution of hydrochloric acid with pH of 4.5 has a concentration of H+ ions of 3.16 times 10 to the power minus 5 mole per decimeter cube. What is the concentration of H+ ion in a solution? What is the concentration of H+ ions in a solution of hydrochloric acid with pH 2.5? This is 1 mark. The solution in this case, pH is minus log of base 10 times the concentration. I multiply both sides by minus. So raise 10 to minus pH. That's what you're seeing there. And the answer will be equal to concentration. So that's how you convert log into exponential. So this is a logarithm, and we're converting that into exponential. And now we can find the concentration. So we can say for a pH which is 2.5, so we'll put 10 to the power minus 2.5, and we plug that into our calculator, and that should be equal to 3.16 times 10 to the power minus 3. And so therefore we can write the answer is 3.16 times 10 to the power minus 3. Question 5.7. Which element has atoms that have the same electron configuration as the chloride ion? Use the periodic table. Okay, so we know from the chloride ion, the ion is going to be argon, because chloride ion is a chlorine gaining 1 more electron. If it's gaining 1 more electron, it will have the same number of electrons as argon, because chlorine is next to argon in the periodic table. Chlorine is a group 7, argon is group 8, so just one more away from the table. But how do we do that? So what we've done is, this is the atoms we got, number of protons, number of electrons. Chlorine is 17, 17, 17. That's just chlorine atom. But when chlorine gains 1 electron, it becomes chloride. So you got 17 and 18 because chlorine has gained 1 more electron. So this one here, what atom has the same electron as chloride ion? It would be argon, because argon has the same electron here as chloride, and argon is next to chlorine in the periodic table. Argon is in group 8, chlorine is in group 7.